All right, hi. I'm Ian. I was part of the Utah Winter Fine Particulate Study with ammonia measurements in Cache Valley and along the Wasatch Front, looking for some of the sources. So why is ammonia important? Ammonia is part of the particulate matter known as ammonium nitrate. This is formed via the acid-base reaction of ammonia and nitric acid. And previous studies have shown that ammonium nitrate is often one of the main constituents of the PM2.5, especially here in Utah. And this is the prevalence of a secondary ammonia compound, indicates that there's an abundance of ammonia in the air. And furthermore, measurements have shown that several of the Wasatch Front cities and in the Cache Valley consistently recorded some of the highest ambient ammonia concentrations in the country and sometimes anywhere in the world. So the PM2.5 is so small that it's able to get into the deep lung tissue, and this affects our health and can cause many heart and respiratory illnesses. So we're even finding that most of the PM2.5 in Cache Valley and in the Wasatch Front is actually PM1, which can go from the lungs and then get into the bloodstream. So that's even worse. So we have a long track record of measuring ammonia in the Cache Valley, especially Dr. Martin has. They began recording data along the Wasatch Front in 2002. And then last year, Cache Valley was at about 65 parts per billion for ammonia, and Wasatch Front was about 8 or so. This year, we found a little bit different data for some of that. So those Wasatch numbers will be thrown into some disarray especially. These are the ground level contour maps for 2016. The scales are not the same between the two maps. Wasatch Front is on the right, and Cache Valley is on the left. Each area had 10 different sample sites measured. There's a nice bullseye in the Cache Valley site, and that is near Lewiston at a large poultry facility. That year, the poultry facility had around 1.5 million chickens. This year, it had around 2.5 million. And then you can see a small ridge that comes down a little bit in Cache Valley as you go towards the southern end of the valley. So the Wasatch Front had much lower ammonia overall, and we did see a couple high values there, such as in Ogden, but each one had a particular period. The sites in the Wasatch Front that had just a single spike. So overall, the data looked pretty good. And then we found no reason to throw those numbers out. So, but other than that, fairly continuous across the Wasatch Front, pretty trustful numbers. So this year we had a real-time monitor set up. We used a Picaro G2508. This is a picture of it in the EPA trailer. And it had a heated inlet to stop ammonia from sticking to the Teflon tube. We sampled for the period about 1.5 months from the middle of January through to the middle of February. We also use these things called Agawa passive samplers. They're very small samplers. You can set them up pretty much anywhere. They have perforated end caps and then a plastic shield that goes over the top to keep out wind and rain. We had 25 sites across the Cache Valley and 11 sites along the Wasatch Front. We put some of the passive samplers in Cache Valley where we knew there were higher emission sources, like the poultry facilities, dairies, and mink fur production farms. And then we were able to do 3 7-day sample periods for this. Dr. Silva from the USDA did our IC analysis for us this year, and then each sample was analyzed in triplicate, and those numbers were very consistent across each sample, so that was good for us, and we trust that data quite a bit. So this is a view of Cache Valley. I don't know if on this screen you can see very well, but it's a big bowl, and it's a valley surrounded by mountains on every side. There's a small outlet near Cutler Reservoir, and then this is a closer up view. So you can see our main sample sites. You can see the DAQ site in the north, and then the EPA trailer in the south, which is just on the corner of USU's campus. And that's where our real-time sampling was done. So this PM2.5 data is from Hawthorne and Smithfield. And as you can see here, it captured parts of 3 spikes from the middle of January through to the middle of February. So that was good, so it gave us some highs and some lows that we were able to compare. So this is the carbon dioxide data and the methane data. The spikes are not quite as dramatic as the PM2.5, but we do see increases during those inversion periods here as well. So now the focus of the measurements, which was ammonia. This is the ammonia data. As you can see, it's climbed fairly high during those, and it drops back off during non-inversion periods. And then when you can compare that to the PM2.5, you can see that it tracks pretty well. There was one issue here that we found where there was a ammonia depletion event. We're not really sure what happened there. It could be from high nitrate, something like that, a lot of cars driving that day, or ammonia absorbed into the fog, possibly. So we took some batch categories during these inversion periods, which are also known as cold pool formation events, to look at what the average ammonia concentrations were during inversion and non-inversion times, so that we compare those to the average PM2.5 concentrations. Obviously, during inversion periods, the numbers are going to be much higher, and during non-inversion periods, we have lower, but we found the ammonia was still fairly high even during non-inversion periods, and then the PM2.5 was fairly low. And then this is the passive work. This part was really fun. We got to go out and do a lot of work in the field, a lot of data collection. So this was better than just sitting in a lab watching a machine work. So on the left-hand side is Cache Valley, with the sample sites spread all over from the north, south, east, and west. We went well up into Idaho and then all the way down into Paradise Canyon. And the Wasatch Front is just more of a long string of vertical sites, and then goes from Brigham City down into Spanish Fork. We had really good coverage north and south, but as you will see later, I wish we had 25 sites like we did in Cache, so we could get a better east and west grid. So here's the data for Cache Valley for the 3 different sample periods. This is shown based on each sample site. There's a fair amount of variability from site to site and from week to week, but overall, all the numbers are very high. So particularly the one called Lewiston Rural, which is near that same large poultry facility that now has around 2.5 million chickens. This is by far the highest. Hiram 6800 South was near one of the fur production facilities, and that's also an area that was a spike for us. Franklin East is near another poultry facility in Idaho that has around 1 million chickens, sometimes more. And then so overall, we had quite a bit of variability, but from week to week and site to site, but all the concentrations were very high. The Logan site is near the EPA trailer where the constant measurements were being taken so that we could compare the two. And then overall, the rest of the country, unless it's ag dominated, is usually just a couple parts per billion. So you can see how drastically it is a problem here in Logan, where it's upwards of 350 some places. We have the highest ammonia anywhere recorded in the country. And then here in the Wasatch, these numbers were a little interesting and kind of surprising. They were higher than last year by quite a bit, even though they're fairly homogeneous across all samples, with a few exceptions, especially being in the south. Linden, that one's in the south, had a sample that wasn't good, so that one was thrown out, and then had another one that was very high. So Spanish Fork is also in the south. That one had a couple high numbers, so did South Jordan. And then the University of Utah had a single sample in the last week that was really high, but we don't really have a reason for that one as well. Some of the reasons for the southern sites being especially high is that there's a fertilizer factory in Utah Valley, and that could be one of the possible sources. Meteorological colleagues of us have found that there is meteorological flow from Utah Valley into Salt Lake Valley. So that could be some of the cause for ammonia within Salt Lake. So just to give some numbers to these graphs so you can see a little bit more magnitude, the Lewiston Rural site, where you have an average of 236 parts per billion, and then along the Wasatch Front, there are much lower values compared to the Cache Valley overall. And then next are these numbers for this year's on the contour plots. On the left here is a contour plot of ammonia in Cache Valley, and on the right is the contour plot of 2016's Cache Valley. So just like in the previous year, you see the large bullseye in the middle in Lewiston near that poultry facility. But this year we also see the higher load in the upper right corner where we had more sample sites this year. And then you can see that slight lobe extending once again to the southern part of the map towards Hiram. This is near the fur production farm. We have very definite contours between Cache Valley between the years. These look really well, and were very well replicated. The absolute values were surprisingly similar. Even for us, we were pretty surprised at how well it worked out. 78 parts per billion of ammonia for 2017 and 65 parts per billion for 2016. The PM2.5 values were also very close, with an average of 20.3 micrograms per meter cubed for 2017 and 18.1 micrograms per meter cubed for 2016. So we were really happy about this, especially with how hard it is to measure air quality and compare the two things from a year-to-year basis. And then along the Wasatch Front. So on the left, you can see the Wasatch Front for 2017, and on the right is the Wasatch Front data from 2016. And the 2017 numbers are spread out a lot higher, but just like in 2016, we don't have much of an east and west grid. This year, we were able to have a 150 kilometer long map compared to the 60 kilometers we had in previous years. And the overall average this year was 31 parts per billion, which is pretty high for this area compared to previous studies. And that high value at the University of Utah was a big, really swayed that up. So maybe a couple of exceptions, but overall the data looked pretty good. I would like to have the site density once again that we had in Cache Valley, and this is something that we can look at for future projects. The 2016 contour on the left had a much flatter overall profile when compared to what we saw this year, and we're not sure why 17 was so much higher, especially because the data was consistent across all the samples. One possibility is that this year we sent off the data we measured. Last year we measured ourselves, and it could have been some issues we had last year with lower concentrations, not being able to read them, or something like that. Or maybe this year there was more bleed in from Utah Valley. And this was just kind of a fun thing that we thought it would be good to do. So we put some of the passive samplers inside some houses. And the one on the far left is a normal office building. It's in the Civil and Environmental Engineering office on campus. There's 5 to 6 people. And then the house number 2 is a normal house, normal family, 4 people, 3 cats, 1 dog, still kind of high at around 150 parts per billion. And then here in the middle, we have house 1 of one of the professors at USU that he and his wife live with 20 cats and 1 dog. And you had over 1 part per million ammonia, which can start affecting your health levels just by being in the house. So that's not good. So through this, we thought maybe we can start to consider certain residential areas as ammonia sources depending on what the outflow is. And then this is the developing study that we just got the data on this week. I have a poster on it in the back. And we did a study over a mink farm. I didn't know that there were mink. I didn't know that a mink farm was a thing. I thought people hunted them and trapped them in like Canada and Russia, and that was it. But we found out there's a lot of them in Cache Valley. And so we, through some connections with the extension office, we got to visit a mink farm with 15,000 mink, and we got to do a similar passive study there. And that was pretty interesting, and we have some of the preliminary results done. So for a future study, look out for more papers coming from that. And then just to summarize the data we stated in earlier slides, for the real-time ammonia averages was around 30 parts per billion this year, and PM2.5 was around 23 micrograms per meter cubed, and that concentration increased quite a bit during the cold pool formation events to 44 parts per billion ammonia and 37 micrograms per meter cubed PM2.5. And then during non-cold pool formation events, that dropped down to 10.2 parts per billion ammonia and 5.2 micrograms per meter cubed PM2.5. The passive samplers indicate, when compared to our real-time sampling, that the EPA site in Logan is representative of the valley. And then the contour maps between 2016 and 2017 for Cache Valley indicate that we have a pretty good idea of the main sources there. For the Wasatch Front, the high difference in the 2 numbers indicate that we need future studies and to have a better grid pattern. So, thank you, and hope you like my slides.